All right, so it looks like most of us are here already. I think we're expecting 16 or 17 possibly. So why don't we get started? It is 10 o'clock. And so now, welcome to Math 1600, which is our introduction to statistics. And there's a few things we want to go over today before we start the actual material. And so now, of course, this is a very intense 4-week class. We're going to try to cover 16 weeks worth of material in 4 weeks. So we have to not waste any time, that's for sure. And unfortunately, that also means that there will be multiple assignments every week. But I'm hoping that since it's Christmas break, you'll have plenty of time to work on them. And so the first thing I want to show you is the syllabus. So let me get that open here. Let's see, I got it open here somewhere. There it is. Okay, so this is, by the way, this is available on Moodle right now as we speak. In fact, why don't we do this? Let's go over to Moodle first before we look at the syllabus. If you do, or I think some of you may actually not be purchase students, so you're not familiar with Moodle. Moodle is the website that they use here to keep track of all the information. Actually, I don't see it. Let me open it up again. All the information is on Moodle. If you go to purchase.edu and go to Moodle, you'll see that hold on a second. I'm already logged in here. You have to log in, and you're going for winter of 2021. This is what they choose to call it, 2021, Introductory Statistics. So up here on the top are the course announcements, which I sent out a couple of them. I wanted to make everybody know what was going on with the class times. Also, yesterday I posted an announcement, which I should have done earlier, I think, about calculators. Now, this is obviously the kind of class where a calculator will come in mighty handy. You can actually do all this work by hand, but I wouldn't really recommend it. You don't need to have a high-powered calculator, but the one that I find that is the most successful for a class like this is the Texas Instruments 83 or 84 or something in that neighborhood. You might have a more advanced version of that. You might have the 89, you might have the Inspire, but the TI-84 is the one that I use. And the reason why I like it so much is because it's not just powerful, but a lot of the functionality that we need is already built into it. So you may have one of these left over from high school. I don't know, a lot of high schools, I think now use the 83, 84 series. So if you've already got one, that's fantastic. If not, it's not cheap, but if you're going to take any more courses, in any quantitative courses, or even finance courses, really, there's so much power built into this calculator. It might be worth your while to get a hold of one. And even at this time of the year, with Christmas bearing down on us, you should be able to get it sent to your house from Amazon very, very quickly because, there's no real shortage of calculators, that's for sure. So I'm going to leave that up to you, but that would be my recommendation. And as we go along, whenever possible, I'll show you shortcuts and hints as to how to get your work done more quickly with the calculators. Okay, because the reality is, I mean, as we get towards the end of the course, a lot of the calculations are quite complicated. And so it really helps to have something like this that you can lean on. All right, so having said that, what else is here? Besides the announcements, let's see, what else do we have here? All the notes for the class will be posted right here. So for example, today we're going to be looking at chapter 3, and you can download it right here. And you see that everything is right where you need it. These are the notes that I've written for this class. And the nice thing about this is that you can read through it at your leisure. This is what I'll be covering in the class, but it's nice to be able to take a look at it after we're done. And there's a problem set for each of the chapters, and we'll get to that later on, not just right away, but we will have problem sets for each chapter. And eventually, now, the reality is, since this is such a condensed course, it won't be long before we have to start thinking about our first midterm. Yeah, I know, it's hard to believe. It's true, though. The midterm, and I'll discuss this with you as we go along, but the first midterm is based on chapters 3 and 5. So when we're done with those two chapters, you'll already be eligible or ready to take the first midterm. But before we do that, I have a problem set here called the sample midterm, which basically tells you everything you need to know about what's on the actual midterm. So this way, by the time we get to that point, You will have had practice with the chapter 3 problem set, the chapter 5 problem set, and the sample midterm. So there'll be no surprises. Okay. You'll have everything you need to know to get through the exams. So that's our Moodle. So as we go along, I'll continue to add more material here. If there's any announcements, I think that when I post an announcement, you're supposed to get an email. Has that been the case? Has anybody actually gotten an email when I sent out an announcement? Or did you notice? There should theoretically have been. If not, I'll just, I don't know. Every system is different. Some schools I use Blackboard. Blackboard, as far as I know, sends out emails automatically when I make an announcement. So if not, you should look into it. Okay, at least check and see, look in your inbox. Oh, we got some chats going on here. It did. Oh, good. All right. I wasn't sure. I can't tell. It doesn't tell me that it's, it just says, all right, there's your announcement. All right. That's good to know. So as soon as I send it out, I know everybody's seeing it. Now, having said that, the thing is, emails are not perfect. Things can get lost. So if you're finding that you're not receiving the materials that you're expecting, like, for example, if you're not getting these messages, if you're not getting the invitations, that means you have to let me know right away. Now, where am I? Let's go look at my inbox here. There's a couple of emails that you can find me at. My inbox is here. And what I'm going to do is send myself a test message right now. Here I am, Alan Anderson at purchase.edu. You can send things there if you want. Or the announcements that I sent you, or the invitations rather, are actually coming from my own Gmail account. I just find it easier to use it with a large group of names. That's why. And I don't mind that you know my personal email address. That's okay. All right, so here it is here. It is, and I'll send an email right now so you can see what it is. And of course, it's, there we go. If you want to reach this email account, you can send it to DOCTORAA 2012, there it is, at gmail.com. That doesn't show it. DOCTORAA 2012 at gmail.com. That's my account. So that would have been the address that I used to send your invitations. And again, it's because it's easier with Gmail than with the purchase account to string together a group of names on the distribution list. For some reason, it doesn't seem to work well with the purchase email. So this is the way I usually go. So there's the email address. So now you've been introduced to Moodle. Let's see. I keep losing it. Where does it go? I've got so much stuff open here. I can't find anything. So, all right. So we've already seen Moodle. You've already seen my email account. What else do we know? Oh, and I've discussed calculators with you. So let's go back and finally look at this syllabus for a second. There it is. Okay. So everything is here. I've actually got a phone number there. If you really are desperate to call me, you have to let me know that, something's going on and you can't make class, or there's something usually you should save that for really emergencies, things that I need to know immediately. But for the most part, emails will do the job. I do still have an office somewhere. There's probably cobwebs beyond belief in my office. I haven't been inside of it since March, and I'm hoping that they're still cleaning it. But anyway, so there's the phone number, there's my email. This is my purchase email. There is a book for this class. It's a very good book. You don't have to buy it. All the material is in the slides. But if you're thinking about taking more stats courses, you might want to get a copy of this book because it's good to have it as a reference, if nothing else. And it's not all that expensive. And then finally, we have this recommendation for the Texas Instruments calculator. Now, what are we going to do this semester? Well, this is an introductory course to statistics. This is the same course you would take in any business school, or you might take a similar course in a more applied department like the psychology department or biology. This is the standard introductory material that you would get in any college statistics course, and you can use it in just about any course you can imagine, finance, for example, or economics, or you'll see it in a lot of different applications. And also, if you go on to graduate school, uh, you might find yourself needing a lot of statistics. And so this is a good starting point. Now, it's also, in my opinion, very interesting for its own sake, but you'll find that more importantly, it is extremely used heavily in the real world. All research is done based on statistics. Marketing is done based on statistics. I mean, when you think about it, how does a company know what their customers want? It's all done with statistics. Or how about insurance? How does an insurance company know how much to charge you for your policy? Well, because they use statistics to determine the likelihood that you'll file a claim. Okay. So statistics is everywhere. And so this is not only useful for, of course, getting your requirements fulfilled, but also for learning a lot of important information that you'll find is very helpful in your future coursework, especially if you're getting involved in some business discipline or other. Okay, now, or on the other hand, if you're a math student, you'll get the opportunity to take even more courses in this area. Any way you look at it, this is going to be very, very helpful to you in the future. So well done choosing this course for your Christmas break. This way, when you're done, it will at the very least loosen up your schedule in the future, and you'll feel like you've accomplished something really important during this period, which, you know, it's easy to let time get wasted during Christmas break. This way, something very important is getting accomplished. So anyway, these are the chapters we'll be covering, three, not four, but 3, 5, 6, 7, 8, 9, 10. And so these are the grading schemes. The problem sets will be worth about a third of the grade. There'll be 2 tests and a final. Yeah, I know it's a lot for 4 weeks, but it has to be done. And so that's where we're heading. So, oh, now here's another topic that I want to go over. What about the class itself? Well, we're actually recording this. Okay, all of these are going to be recorded. Why is that important? Because you may want to watch it again when we're done in case you missed something. Or if, let's say, one day you can't be here, okay, something happens. Who knows what can happen? So what I've been doing is I put the recordings on my YouTube channel only because the Moodle will run out of space very, very quickly. These recordings are very, very space intensive, which I discovered the hard way in the spring. After I got a few of them posted, it just ran out of space. But YouTube apparently seems to have unlimited amounts of memory. So I've been putting them there. Now, if you go to YouTube, and I'm still kind of an amateur with YouTube, I am sure there's many things I could be doing here that I don't know about. But what I've discovered is that the easiest thing to do is to put it in what we call a playlist. Because you can see I've got so many classes, or I did have before the semester ended, all these classes going on. And they would, if the videos were all jumbled together, you would never find them. So instead, I have for each class at each school, I have a playlist. So after today's recording is ready, I'll be able to create a playlist for this class as well. Okay, so just look for Math 1600 under SUNY Purchase, and the videos will be there for you to download and watch them. And I don't know if it's possible to rank them or rate them. It's possible you can give it a thumbs up if you feel the need, but I'm not interested in that. I just want to make sure that you can watch these if you feel so inclined, and especially if for whatever reason one day you're unable to come to class. Okay, and so that's why they're here. And you know, some semesters people watch them a lot, sometimes they don't need them, but this is where they are. And so I think if you just go to a random YouTube, let's do this. Again, this is because I'm so not a technology expert. I think if you go to just a plain YouTube channel and you search for my name, I think you'll find me. There you go. Okay. Apparently that's how it works. By the way, you can feel free to watch these other classes if you want. I mean, really, they're sitting here. They're all publicly available. Every so often, I discover people who don't go to these schools watching them. It's kind of fun to think about that. Like somebody really wants to learn out there. That's great. And what's funny is every so often YouTube sends me emails and they can see the numbers. They can see that I've got a lot of it. The computer sees that I've got all these videos and a lot of numbers. I guess they misinterpret that as some kind of a channel where I've got very popular videos on it or something. They occasionally send me helpful hints for how to make money, how to make more money with my channel. Like, wow, look at all these people who are watching your videos. Have you ever thought about how to make money with it? And I feel like, well, all right. No, that's not what's going on here, but still, they are under the impression that I've got this very popular channel going on, and that people must be willing to pay money to watch ads on my channel. So anyway, so now what else do we need to go over before we get started? I think that's about it. Oh, and the timing of the class, yes. So I picked 10 o'clock because it's not too early to get up. Nobody should be unable to get up at 10 o'clock in the morning. That's my opinion. Okay. Even though it's Christmas break. Now, it is a long class. Now, I figure in order to finish on time, we need roughly 2 hours each time we meet, but there will be a break in the middle. There has to be, because it's a lot of very intense content. There are some gaps in the schedule, though. For example, this week, we're not going to have a class on Thursday because it's New Year's Eve, Christmas Eve day, I guess. The following week, I think, is back to normal. Yeah, that might be it. That's probably the extent of it. There's also a possibility that next Monday I'll be returning from a trip where I may not get back in time. If that happens, I'll send you an email, and what I'll do is I'll make the recording and then you can just watch it. I'm not sure. I might find myself traveling over the weekend, and if that happens, there's a chance at least that on Monday, only this Monday, I might not be able to get back here in time. So if that does happen, like I said, I'll send you an email plenty of time in advance and just say, listen, on Monday, we'll just have a recording and no class. It would just be that one time. That's it. After that, everything was completely normal because we'll probably be snowed in the whole time anyway. So, all right. Anyway, I think we're ready to go. So now I discovered by accident that this system we have here allows for the possibility of taking polls. So I just want to check this out today because I have a legitimate reason for this. What I'm going to do, you can see what I'm doing, I guess, is type in this question. And okay, here we go. So the question is, do you have any background in statistics? And the choices will be, oh, okay. I guess that's all I'm allowed to do. So I'm going to post this and we'll see what happens. This is just, I mean, not that it makes any real difference. We're going to cover everything from the ground floor up anyway, but I'm just wondering if people have seen some material before, or if this is literally brand new. So I don't know how this works on your side. Is everyone seeing the poll? No? Oh my God. Oh, no, I didn't hit the right button. Sorry. There we go. You should see it now. Like I said, technology is not my thing. Okay, so this is pretty much what I expected. So I was going to do this anyway. I'm going to literally assume that you've never seen any of this stuff before in your entire life. It's not the worst idea in the world. Even if you have some background, it's probably been a while. So that's fine. So we're going to start at the very, very beginning. And so why don't we get started? Now it's already, for God's sake, 20 after 10. Like I said, we don't have a lot of time to play games. So why don't we dive right into it? And anytime you want, you can ask questions through this chat room thing. It flashes orange when you send in a chat, so I can't possibly not see it. You can send it to me apparently in two different ways. You can send a message that everyone can see, and you can send me a private message If you're like, if you say, well, I don't understand this and I don't want everyone to know it, that's okay. Just send me a message and say, listen, could you go over that again? And I'll do it. So this is your way. I don't know if, I think you can turn on your microphone and verbally ask a question too. So again, like I said, this is not my thing, but you can check it out if you want. Just say, listen, I don't understand what you're doing. That's okay. Because I need, in a normal classroom setting, I can see when people aren't following or they're not understanding, and I can do it again. I can't see you, not really. So if you really are not sure about what's going on, you really have to say something, because otherwise I'll just keep going on. All right. Okay, let's do it. What's this all about? Statistics. All right, so we're going to start at the very beginning, and here we're going to introduce some basic terminology. Now, most of this class does not involve a lot of terminology. There's some classes, there's tons of vocabulary. Like biology, you spend half the time memorizing stuff. Actually, I can't remember who said this, but I read it somewhere where somebody said that if you pass a biology class in college, you feel like you could memorize an entire telephone book. I guess they meant that there's a lot of terms in there. Not so much here. There's some basic terminology. More than anything, there's new symbols that you'll need to get used to. Mathematical notation, which is very compact, but it gives us a lot of information. And so we'll introduce that as we go along. Also in statistics, we tend to run into a lot of Greek letters, which I'll introduce as we go along. And you'll see why we need them. So why don't we start by introducing one of the more important concepts here, this idea of populations and samples. All right, now, everybody's heard the word population before. And normally in everyday usage, it's taken to mean a group of people. And that still could be the case here, but in statistics, we're more interested not so much in the people themselves, but their characteristics. Like, for example, what if the government decides we need to know if the average age of all Americans is increasing? Because if it is, we may have to make some changes to the Social Security system. So in their case, their population of interest would be the ages of everybody who lives in the United States. Now, calculating the average of those ages could be quite a challenge, because let's face it, there's over 330 million people living in this country. So instead, they might be tempted to try the following. They might say, listen, do we really have to count all 330 million people? Why don't we try this? Why don't we gather a group of people that appear to resemble or reflect the overall population? Okay, so we're going to pick not everybody, but we're going to randomly pick people from our data sets, and we will use their ages to represent the entire country. So if they do this well, they do it carefully, the numbers they come up with could be very realistic estimates of what's happening in the overall population. So when we do this, when we take a smaller group from the population, this is referred to as a sample. Okay, now you've heard the word sample many times. Sometimes you go to the supermarket and there's a lady standing there with little cheeses and they're handing them out to you on toothpicks. Those are samples. But this is a different kind of sample. This is a subset. Now, by the way, that reminds me too, as we go along here, we're going to eventually need to review a little bit of what we call set theory, okay? You have all been introduced to sets in the past. You possibly have started to forget what you learned, but we're going to, as we need it, review the concept of sets. Like, here's a perfect example. Let's stop for a second and remind ourselves what the word subset even means. So let's say we have two sets. Let's say A is the set that contains the numbers 1, 2, 3, 4, 5. Okay. Now remember how sets work. A set is a collection of objects, and they're listed. The order is actually irrelevant here. I just chose to write it as 1 through 5. The order doesn't really matter. It's a collection of objects, and then B, let's say, is 1, 2, 3. Now, what we do is make the following claim: B is a subset of A, because now, why do you think that is the case? All right. Who knows why this is called a subset? What is the logic here?
Because 1, 2, and 3 is included in A.
That's exactly right, because B is completely contained within A. Now, there's all the elements in B are in A as well. Now, suppose I introduce another set. Let me do that right here. Oops. Now you can see clearly that C is not a subset of A, because some elements of C are not elements of A. And it's just that simple. Okay, so that's our set theory review for the day. There'll be plenty of others as we go along. There's one chapter in particular where we'll need a lot of discussion about sets, but for our purposes, that's enough. So when it says here that a sample is a subset of a population, it means exactly what it says. In other words, this B, if you think of these as, let's say, not just numbers, what if instead I found 5 people for set A and 3 people for set B, and all 3 people in set B are also in set A? That counts as a subset. All right, so some simple examples of these. Let's say that there's a large university that wants to understand what's going on with the GPAs of their students. So, they may not have time to look at all of them. So instead they pick 10 at random. And if they're really randomly chosen, their GPA should reflect the overall student body, which would constitute the population here. Now, here's a slightly different type of example. This is not taken from real data. This is more of an experiment, which we'll see a lot of that as well. Sometimes our data comes from experiments, and sometimes it comes from actual raw data. So here we have a deck of cards, and we pick a card at random. Whatever that card is, that is considered to be a sample taken from the deck, which could be considered a population, because that one card is in fact a sample or subset of the entire deck. Now, so samples, the properties of these samples that we're choosing are used to estimate the properties of the underlying population. The accuracy of this process, of course, depends on how closely the samples reflect the underlying population. So let's say, for example, when the US government decides to use a sample to estimate the age of the entire country, would it be smart for them to choose a random selection of just SUNY Purchase students? Would that be a good move to use that to represent the entire country? And if not, why not? Oops. No ideas. Well, what's true of the ages of the students at SUNY Purchase? Do they reflect the entire population? Of course not, because most people are between 18 and 21 at the school. So that would be a very terrible choice, and would give them a very distorted view of the average age of the entire country. Okay, now, what do we do with our sample data once we gather it up? There's certain key details that we really need to understand within any set of data. So we're going to start by looking at a group of measures, they're called numerical measures, that give us a quick view of the properties of that sample or population, as the case may be. So we're going to start with a group of these measures, which are called measures of central tendency. What is that all about? Well, what we're doing with these measures is we're trying to find a number in a sample or a population around which most of the elements are located or concentrated. What does that even mean? All right, so we're going to look at 3 of these measures, and I'm sure that you'll recognize at least some of them, if not all of them. Okay, are you ready? So the 3 we want to focus on today are called the mean, the median, and the mode. Now, I'm going to have a poll right now just because it's fun. And let's end that one. Let's start a new one. No, I need a new poll. It's oh boy. Oh, here we go. Oh, wait, that's the title. No. I'll just call it survey. Yes or no? Just out of curiosity. And what happened to it? Now this one is still here. Oh, here we go. Now it works. Okay, good. So the words mean, median, and mode. Oh, 100% say yes. Excellent. That's what I like to hear. All right. Now, I'm going to ask you this another, one no. Okay, now here's the other question, which I don't want to waste any more time, but do you remember what they mean? Ooh, that's the big question. I'm going to say maybe. It's a big maybe. So, by the way, I do want to mention that the word mean is also known as average. Okay, so what do these actually represent? Now, before we go any further, I want to mention here that these measures can be applied to both samples and populations. So in some cases, we'll actually define a separate formula for each case. So we're going to start with the mean of a sample, okay, or the average of a sample. Now, we're going to introduce some very important notation, which may look scary at first, but you'll see pretty quickly it really isn't, okay? Now, all statistics formulas are meant to be compact and very general and useful. So the trade-off, though, is that they look frightening when you see them. So we're going to learn very quickly how they work. So let's start with the sample mean. All right, here it is. Now you see what I mean? It looks kind of scary, but let's pick it apart piece by piece and see what it really means. So this is referred to as X bar. And this is traditionally used in statistics to represent an average or a mean. This little bar is almost always used to represent the fact that this is an average. Now, why is it called X? We're assuming that we have a sample of data, and the sample elements themselves will be referred to with an index. Okay, so in other words, let's say we have 3 elements in our sample. The sample elements, whatever they are, would be referred to with an index, by which I mean X1, X2, and X3. So the subscript is telling me which element I'm referring to. We're going to use the letter I to make this as general as possible. And based on what you're seeing here, I equals 1 to n means I has all the values from 1, 2, 3, 4, 5, all the way up to n. Whatever n happens to be, I covers all of these positive numbers, integers as they're called, from 1 to n. And this symbol, this is the big mystery of the whole slide. This is the Greek letter sigma, and it is used in math to represent the so-called summation operator. There's whenever you see sigma like this, it means you're going to add something together. In this case, that something are the elements of my sample. So this could actually, this whole numerator can be replaced with x1 plus x2 plus all the way out to xn. So you can see it is simply a compact way of saying x1 plus x2 all the way out to xn. And this n itself is the sample size. In other words, how many elements are in your sample. So when you come right down to it, all we're doing is saying, listen, if you want to know the average of a sample, add up all the elements in that sample and divide by the number of elements you have. Now, intuitively, everybody knows how to calculate an average, and this is how it's done. So that formula isn't so scary anymore, is it? No, it is not. All right, so by the way, we'll see this sigma all the time in statistics. It comes up frequently, to say the least. Okay, so just another recap here. X bar is the sample mean. Sigma is actually the uppercase version of sigma. There's a lowercase version, which we'll see later on. We use this to represent the summation operator. I is referred to as an index. This is how we keep track of all the x's, these sample elements. And xi is a single element of my sample. It is indexed by the letter I. And then finally, n is the sample size. Now we're going to take a bit of a detour here. We're going to briefly review the properties of the summation operator because we'll need them in our later formulas. Okay, not just for the fun of it, although it is fun, but because we really need them. All right, so what is it being used for? Well, of course, we're going to add together some elements. So let's say we have a sample that has 5 elements in it. Okay, and you can see they're numbered. The indexes range from 1 to 5. Okay, here's the 1, 2, 3, 4, 5. And those are their values. Okay, let's say that these are the temperatures during Monday through Friday during a random week chosen in February in Toronto. These are Celsius temperatures. And so there's 5 of them. Now, I want to know the average of these sample elements. Well, what I'm going to do is in the numerator of my summation formula, let's go back here. I'm going to do the numerator first, which means just add them up. And so formally, I'm doing this. Xi equals x1 plus x2 plus all the way up to xn. But in this particular case, I'm adding them up from left to right, and I come up with 10. Now, before we go any further, I just want to show what other ways can we use the summation operator. What if we encounter this case? Ooh, look what happened here. All of a sudden that x is squared. So if you take these same elements and apply this expression, what it's saying to you is that you must square each term before you add them up. Okay, square them all and then add them up. And you can see instead of getting 10 as our sum, we're getting a 40 because we squared them all before we went any further. Okay, so you can see it makes logical sense. Each squared term has to be added up. But what about this case? There's a way, something that looks similar, but it's different in a very important way. The squares on the outside of the entire expression now. How does that change our results? Well, what this is doing is saying add everything up inside the parentheses first, and only then do you square your result. Okay, so that's very different, isn't it? Instead of squaring them and then adding them, you're adding them and then you're squaring them. And so if you plug in our numbers, the same numbers, our sum was 10, if you recall. 10 squared is 100. So clearly, these two are not the same thing, are they? Not the same. So we have to be a little careful with this notation. Well, now this one is very complicated, but we're going to need it later on in this chapter. There's 3 parts going on here. I have to subtract the k. The k is a constant, by the way. It doesn't matter what it is. It's just some constant. And I have to subtract that from each element in my sample. Okay, subtract, oops. Okay, subtract k from each sample element to square the result. Add them up. So it's a three-part process.
Will K always represent a constant, or is this case specific?
Well, the k itself is always used to represent a constant, but you'll be given a specific value of k.
Okay.
Yeah, in other words, otherwise, what do you have here? You have something very bizarre and not specific. You'll see in the next slide, we have a very specific example. Yes, this is just to show you the general case. The specific case that I want you to see is, what if we take the data we had before and subtract 3? I just arbitrarily pick 3 and then square the result. So you can see from all of our sample elements, I'm subtracting a 3, and then I'm squaring that difference to come up with these values, and then I add them up and I end up with 25. Okay, so again, it's hard to believe now, but this will come in very useful in just a matter of maybe 20 slides or so. Okay, now obviously these summation operators can get much more complicated than this. But for our purposes, this is all we need. If you understand what we just did, you're fine. Okay. And we're not going to spend a lot of time looking at abstract formulas anyway. I mean, there's some, but we're trying mostly to do generate results. And so this is just a shorthand way of saying, this is a very compact way of saying do all these steps. And so the purpose of mathematical equations and formulas is to make things more compact. Okay, so if we go back to our original example, in the numerator, again, you're adding up all these numbers. Now, since there's 5 elements in our sample, we divide our sum by 5, and it turns out that our mean is 2. So the average temperature in Toronto that week was 2 degrees Celsius. And that's what this is telling us. Now, intuitively, everybody knows what an average is. I mean, you do these all the time. Let's say you go to a restaurant and you're trying to figure out how much everybody has to pay, and you don't want to get into an argument. So you decide, we'll just average it out and figure out how much on average everybody bought. And that's how we'll figure out the tip, or that something along those lines. You got 5 people in the group, figure out the total that they spent, divided by 5, and you've got your average. And everybody throws money on the table, and then you leave, and then everybody's happy. Okay. As long as nobody bought the caviar and there's average, push the average to the roof. So this is the average or mean. Okay, so I think intuitively everybody understands this. The only thing that's really new here is this notation. And yeah, we'll see a lot of that as we go along. Now, there's a separate formula for the population. Is the same formula, only a few of the terms are slightly different. For example, what is this? This is the Greek letter mu. It corresponds to the M in the Roman alphabet, which, by the way, our alphabet is the Roman alphabet. And so the logic going forward will be that Greek letters are used to represent populations, whereas the Roman letters, in other words, our letters, are used to represent samples. And of course, X is a Roman letter. All right, now the only other change is capital N. We're going to adopt the following convention. Lowercase n is the sample size. Capital N is the population size. The reason why we need to have 2 separate letters for that, or 2 different ways of expressing it, is because occasionally both of them appear in the same formula. And when they do, you have to have some way of telling them apart. So this is the convention that's been adopted. Lowercase n will always mean the sample size. Capital N is the population size. All right. Now, we don't need a separate example for this because, as you can see, you're doing the exact same thing. You're adding up the elements in your population and dividing by the population size. So we're going to move on to something different now. The second of our measures of central tendency, if we recall our list, let's go back and revisit our little list. And you'll see that next in line is the so-called median. The median is another measure of the center of a group of data, but it's done in a very different way. The median, oh, I'm sorry, before we do that, we've got one more thing to look at. We'll get to the median in a few minutes. What I wanted to do is introduce a slightly different type of average that you may encounter, the so-called weighted average. Now, you're already very familiar with this idea. I'll tell you why. Because when you calculate your GPA, your overall GPA, the issue there is that not all of your classes have the same number of credits. So you can't calculate your GPA typically by just adding up the grade you got in each class and dividing by the number of classes, because some of those classes may be 3 credits and some may be 4. And if there's a lab involved, it might be 5. So instead, we need to resort to something which is called a weighted average. Now, weighted average is very useful when we have a sample population where we have numbers that are repeated frequently. Like in the case of your GPA, we have all these different credits. Most of let's realistically are either going to be a 3 or a 4. So how does that work? Now, the formula for this looks doubly scary, but it's not. Okay. There it is. That's the sample weighted average. So what in the world is going on here? Well, we've introduced this new concept, W. This WI is the weight associated with element Xi. What does that mean? This refers to the frequency of Xi in the data set. So the formula is saying, listen, in the numerator, multiply each element by its weight, then add them up. Down here, we'll just add up all the weights. And you've got your weighted average. So it looks scary, but it isn't, is it? No. So, of course, it'll make a lot more sense when we do an actual example. Of course it will. So, are we ready to go on? Oh, by the way, as usual, there is a separate formula for the population mean, weighted average. And again, the only difference is the notation. So let me quickly show that to you. The X bar is replaced with the mu, and the population size is at capital N instead of lowercase n. All right, so again, there's our old friend mu. So we don't need a separate, well, we're going to just do one example now. I think this next example actually does involve a population, but because it's a very small population, we have a lottery. It's a small lottery. Maybe this is, I don't know, maybe a school is running this lottery. It's very small. There's prizes in this lottery. One prize is worth 1,000, 10 prizes are worth 500, and there's 100 prizes worth 10 each. So for the winners of this lottery, what is the average prize that they will receive? Now, your first instinct might be to say, all right, well, this is easy. That would be 1510 over 3, which is 503. Now, is this the correct answer, though? Does that make sense? Would you actually add those up and divide by 3 in this case?
No.
No, because there's a lot more $10 prizes than $1,000 prizes. We have to find a way to take that into account. So I'm going to make a note here. By the way, when we're done, you see all this wonderful writing that I'm doing on these slides. I'm going to put this slide with the handwritten notes in it onto Moodle, so you can look at that one. In addition to the one you have, which has no writing in it, I'm going to put this up there so you can go through and you'll remember all the stuff that I've written in the slides so that it doesn't get lost. Okay, so this approach is not correct. In fact, that's such an important detail. I'm going to actually put some red here so you'll notice that no, don't do that. Because it's not correct, but it should be clear why not. So what do we do instead? Let's assign weights. Now there's two different ways we could do this. The weights could be the actual number of times this number appears in your data set. These are called frequencies. You could also use proportions where these would all be fractions, but let's just stick with this approach for now. These are prizes and these are frequencies. Okay, so this number represents how many prizes have that value. These are the values. So in the numerator of this formula, you're literally going to multiply these out. This is W1 X1 plus W2 X2 plus W3 X3. And then the sum of the weights is simply W1 plus W2 plus W3. And that's what we're about to do on the next slide. We're going to plug in our numbers into those two. And of course, what we're looking for is the ratio of these two, which, let's jump ahead here. Now you can see this is W1, X1, W2, X2, W3, X3. This is W1, W2, and W3. And you can see, far from being $503, it's only $63.06. So why is it so much lower than what we had before? Because most of the values are 10. Okay, notice because there's so many 10s in here, compared to 500s and 1000, it stands to reason that the average will be much closer to 10 than to either 500 or 1000. Okay, that's therefore our weighted average. We save this though for cases when we have a lot of repeated values, or for whatever reason, adding them up is not, and dividing by the sample size is not appropriate, like with your GPA. Okay, in fact, why don't we do this real fast? Just for the fun of it, because we can. What I'm going to do is put together a quick example. Suppose, because more examples are always better than less, I think. This is the kind of material, by the way, where you can really do it with practice. I mean, some disciplines, well, they're hard. Anyway, and this is too, but this is a discipline where you can learn it just by practicing. Suppose a student has the following grades. Okay, so this is your semester. So an English class, English, 3.0 credits, and you got a C, which is worth 2.0, by the way. Let's just put that in there. And then you took calculus 1. And you got 4 credits because it's calculus. And you got an A, which is worth 4 points. And then you took physics and 4 credits again. You got an A. And then you took psychology, 3 credits, and you got a B plus, which is, let's say, 3.3. All right, what is your GPA? Okay, so because of these, what we're going to do is associate the weights with the credits. Okay, so W1, let's call it, is 3.0 and X1 is 2.0. The second weight, the physics calculus, is 4 credits. And for that, this person got an A. So these are the credits, the weights of the credits. The values on the right are the grades. And B plus X4 is 3.3. So think of these as the credits and grades. Okay, well, now once that's done, what we're going to do is put these together and say, well, you know what? In our formula, which I'm actually going to borrow from up here, let's call this a population. It doesn't really matter if we call it a population or sample, because it's going to amount to the same thing. And so we're going to have, we're going to multiply the weights. Okay. Let's see. So the weight of the first class is 3.0 credits, C, grade of C. That was English. In physics, we had calculus, we had 4 credits, and we got a 4.0 for the class A. And then we had 4 credits for physics, where we also got an A. And then we had 3 credits for psychology, where we got a B plus. And then down here we have the weights, which are 3. Okay. So let's see. Let's get out the old calculator. Actually, this is probably big enough. Oh, you know what? Let me finish it up in the equation. So in the numerator, if you take out your calculator, I hope you have one. You don't have to have it with you. If you don't have one today, you can use your iPhone. It's got a nice calculator built into it if you've never noticed it before. But there's just one little trick to using it. If you take it out right now, if you want to use it, go find the calculator app, which comes with it. You can't delete it. But if you want to if you turn it on like this, you'll get this very, very basic calculator, which can barely do the most basic fundamental calculations. There's also a scientific calculator here that you can use. You have to turn the phone on its side into the so-called landscape mode. And if you do, you'll discover that it converts into this amazing scientific calculator. Everything you need is in there, at least for today. If you've never seen that before, well, that was worth the price of the class right there, I think, right? Okay. So the numerator, we have 47.9. In the denominator, we have 14. And that leaves us with 3.42. That's your GPA. Okay. If you had just added them up and divided by 4, you would have gotten something different. Okay. In other words, let's go back and see what would have happened. If I just said, all right, well, let me add these 4 grades up, 2, 4, 4, and 3.3, divided that adds up to 13.3 divided by 4 is 3.33. So you would have been cheating yourself out of a GPA. In other words, your GPA would look lower than it really is. You're being rewarded for having a very high grade in the high credit courses. That's why this is happening. All right. Anyway, now let's look at the median. Finally, we get to do the median. Now the median is very different. Oh, I just realized it's 11 o'clock. So this is a good habit I want us to get into. Because this is obviously a lot of material, I mean, 2 hours would be a bit much, especially day after day. So I like the idea of having a little break right about here. Not a long one, just enough to get something to drink or, do something. Let's come back in about 10 minutes and we'll start with median. And then we'll carry on from there. How does that sound to everyone? Oh, I'm not hearing a lot of yoo-hoo or anything like that. That's okay.
Sounds good to me.
All right, let's give it about 10 minutes should be enough for you to get something to nibble on. You're probably hungry by now anyway. It's 11 o'clock in the morning, for God's sake. So, all right, we'll be back in about 10 minutes. All right. All right, is everyone back? Oh yeah, there's I can see some of you, not a lot of you though. But okay, cool. I'm not sure what difference it really makes. But it's kind of nice. It feels like it's kind of a real class instead of just me talking into space. All right. So far so good. Yeah, good. All right. It's going to be like this every day, by the way. We're going to do a lot of interesting stuff. And some of it you may have seen before. Like I said, now, eventually there may come a point in this course where there's material that you've never seen before. I don't know. Maybe you've never seen any of this stuff before, but so we'll just carry on from here. And now the median, think of it as the halfway point in a set of data. In other words, we're finding a number where half the elements are less than that number and half are greater than. It's right smack in the middle. So let's say you got a score of 70 on your test. And the teacher says to you, you got the median grade. That would mean that half the class did worse than you and half did better than you. So rather than it being an average, it's simply it's a number which is in the exact center of the data, half below, half above. So you'll see in a bit that sometimes this is actually more convenient than using the mean. It depends on the type of data you have. Most of the time we do use the mean, but the median has an important role to play as well. So let's see how this works. Now, here's the same sample data we had earlier, 2, -1, 3, 5, and 1. Now, this one requires an extra step. What we have to do here is sort them out from the lowest to the highest values. Otherwise, it's not really possible to do this. So let's do that. And with only 5 elements, it's not going to take too long. We have -1, 1, 2, 3, and 5. Now, what exactly are we looking for here? What's in the middle? Well, you can see the 2 actually is in the very center of this data. And so surprisingly enough, that's all we have to do. Just identify which element is in the middle. And this certainly satisfies the requirement. 2 of the elements are less than 2 and 2 of them are greater than 2. So with this little graph here, I'm giving you a hint, a very unsubtle hint, that 2 must be the median because it's in the middle. Now there's just one problem here. This works great when we have an odd number of values in our sample. But what if we don't? For example, if we have an even number of elements like this one. Okay, so we'll take the numbers and of course sort them out from low to high. And that gives us 0, 1, 2, 3, 4, and 6. Now there is no value right smack in the middle. So as a compromise, what we'll do is we'll take the 2 that are in the middle and average them out. Okay, so in this case, you can see that we're getting 2.5. Now, 2.5 is not actually in this sample, but that's not really relevant. What matters is that 2.5 cuts the data right in half. Half the elements are less than 2.5 and half are greater, and that's what we're looking for, 2.5. Okay, so really there's only 2 cases here that we have to worry about. An odd number of elements and an even number of elements. It works the exact same way every time. Now, here's a couple of interesting details though. Number one, there isn't an actual formula for the median. It's basically a procedure. There's no way of converting this into a formula, number one. And number two, the population median is calculated in exactly the same way as the sample median. We do not have to make a distinction between the 2 cases here. Okay, so now you're dying of curiosity to know why one would need the median instead of the mean. Good question. Well, what happens is sometimes in our data, we may have something in there which is called an outlier. And an outlier is an element in a sample or a population which is much larger or smaller than the other elements. Well, so let me just show an example of how this could happen to you in the real world. As an example of an outlier, that is, suppose that a student has the following grades on the 5 exams during a course or a semester. Okay, so you got an 80, you got a 90, you got an 85, you got a 92, and all of a sudden there's a 48 mixed in there. What happened? Well, maybe that day you were sick. Okay. And so you would say that, you know, you're doing very well, but you just had that one unfortunate case. In this case, the 48 could be considered to be an outlier, which doesn't really reflect how well you're doing in the course. It just so happens that something happened that day and you only got a 48. And it does happen to everyone. Or here's another one. Another good example. Now, you may be aware of this. At Purchase College, they have this policy where people who are retired can actually take classes there for like essentially free. I don't know if you've ever had a class where somebody was there who was retired. It happens occasionally. I don't know that they would go for a stats class. I mean, if you're retired and you decide to go back to school, I'm not so sure that would be the top of your priority list. You know what I mean? But let's just say that the ages of the students in a class at Purchase College are, so you get like, 18, 19, 20, 19, 18, 20, 21. And then all of a sudden there's a retired person in the back of the room who's 75. Okay. They decided it would be fun to find out what statistics is all about. Okay. So therefore, the person who is 75 could be considered to be an outlier. So what does that have to do with anything? Why does this affect our results? All right, let's find out. Let's look at this example. Here's a sample that has the following elements. Okay, 2, 3, 1, 3, 5, 100. Well, I think we can see for ourselves which one of these elements is the outlier. Now, what does this have to do with anything? Well, watch what happens. Suppose I decide to count or calculate the average. 19. Oh my God. Well, there's the problem. The mean is 19. It's larger than all the elements but one. And for that last one, it is much smaller than that element. The measure of central tendency is supposed to represent the center of the data, but here it doesn't really seem to be doing a good job, does it? Well, what if we try this instead? Let's try the median. Let's sort them out. And now we have 6 observations. Now, just by an extraordinary coincidence, the 2 in the middle are both 3s. So the average, obviously, of 3 and 3 is 3. So in this case, while the mean is 19, the median is 3, which I think you'll agree is a much more useful measure of the center of this data. 3, not 19, 3. So the story here is that when you have outliers in your data, let me just put this down here as a conclusion to all this. The grand conclusion to all of this discussion is that, hold on. The median is a better measure of central tendency when a data set, which means either a sample or a population, contains one or more outliers. Okay, now the rest of the time, for the rest of the cases or other situations, the mean is usually the preferred choice, as it has more convenient mathematical properties. And of course, people understand it better. I mean, most people intuitively they're pretty clear on what a mean is. The median, not so much maybe. Now, the third and final measure of central tendency we'll be considering here is the so-called mode. And the mode is the most frequently observed value in our sample or population. Now, it turns out the mode isn't always terribly useful, especially with numerical data. But let's see how it's calculated. So let's take a look at the sample mode. Here's a sample with the following elements. And by the way, just like with the median, we have to sort our data here. So we do, and what we notice is that, there's 2 3s in there. Well, guess what? No other values are repeated, so therefore the mode of this sample is 3. And it's that easy. Now, here's one of the quirky things, though, about the mode. What if we have something like this? Oh, I didn't have an example. Let me show you an example where it can get very bizarre. A couple more examples. What if we had, and I'll show you the sorted sample. All right, we have, let's say 1, 2, 2, 3, 4, 5, 6, 6, 7, 8. Here, there are 2 modes. And of course, the 2 and the 6. This sample is said to be bimodal. But then let's look at another example. And that would be, let's say, this. So what's the mode here? Since no numbers are repeated, there is no mode. There just isn't one. It doesn't exist. By the way, it's a point of terminology. A sample or population with a single mode is said to be unimodal, and a sample with or population with 2 modes is said to be bimodal, where of course we know that bi means 2, and uni means 1, like unicycle versus bicycle. Okay, so this is, oh, here we go. I think I see a chat. Yes, it would. Exactly. 3 modes would be trimodal. They all have a proper name associated with them. I'm not sure what 4 modes would be. It might be quadrimodal or something like that. We'd have to look it up, but yes, that's absolutely correct. So now, this is one way in which the mode is very different from the mean and median. The mean and median will always have a single value, while the mode can have many values or no value at all. So that's one of the things that makes it unique. Now, the mode can be very helpful for more qualitative applications. Like, for example, if you're a marketing firm and you're trying to find out what everybody's favorite color is, then the mode of whatever survey you take is everybody's favorite color. In other words, if you say, what's your favorite color? And most people say blue, then the blue would be the mode of that sample. Okay, and then you would use that to decide what color to offer for your products. All right, now, just like with the median, we don't have to really make a distinction between a sample and a population mode because they're identical to each other, and also there is no formula here. Now, what we're going to do next is tie these 3 concepts together. We can describe different sets of data by looking at the relationships between their means, their medians, and their modes. So some samples or populations can fall into one of these 3 categories. Not always, but many of them do. Now, again, these are pretty frightening looking terms. We're going to see what they mean. We're going to use a graphical device to represent our data, which you'll see in a second. And you should be able to see just by looking at them what category they belong to. But we're also going to prove them mathematically in each case. Okay, it's never enough to say, well, it looks like this in the graph. We have to have a numerical proof to determine which category our data belongs to. By the way, you probably have heard the word symmetrical at least. Symmetrical means there's a balance of some kind. There's a mirror image going on between the left-hand side of something and the right-hand side. Like your face is more or less symmetrical. If you drew a line down your nose, the left-hand side and right-hand side of your face is more or less the same. Maybe not exactly the same, but it's pretty close. Skewed means no, it's not symmetrical in an important way. All right, so the first case we'll consider is the one where a sample or a population has a small mean, which is less than its median, which in turn is less than its mode. In that case, we say the data are negatively skewed. Okay, now, what does this mean? Now, what I'm going to do is show you a graph, a very special kind of graph. These are meant to represent returns to stocks in a portfolio. Now, let's look at this graph for a second. First of all, this type of graph is often referred to as a histogram. We see these a lot in statistics. We'll see many of these throughout our course. What's important here is if you look in the bottom, these are rates of return to a stock. And the heights of the bars represent how many times that happened, or the frequency. Okay, so the rate of return across here, these are categories. All right, these are rates of return. Up here tells me how many times this happened over a given time interval, that is. Like this could be from the past year, for example. So what that tells me right off the bat is that most of the time my stock either had a loss of 0.5%. You can see this bar and this bar are the tallest. They represent a loss of 0.5% and a gain of 0.5%. Now, one of the unfortunate outcomes of this is that if you notice, most of the returns are negative. There's a lot less positive returns than negative returns. And so the area, you can see there's all the space moving down towards the left. Okay, in other words, the area of these bars is much greater than for these bars. And that means that we have a data set which is negatively skewed. Sometimes it's called skewed to the left. It's like a ski lift. It would come up on this side, and then you would actually ski down this side because this side is too steep. It's very dangerous down here. Okay, but the left-hand side is perfectly safe for skiers. It's a nice, long, gentle slope. But that right-hand side, ooh, boy, is that steep. You don't want to be skiing down here. You'll never be able to stop. Okay. Now, formally, that comes about from this relationship. Okay, there's so many negative returns that the mean is much smaller than the median, which in turn is less than the mode. Now, symmetrical, there's a balance between losses and gains in our example. The mean, the median, and the mode are all equal to each other. And you'll see that the graph reflects that. There's a nice balance between losses and gains. What does this thing look like? Well, look at that. You see how the losses are balanced off by the gains. And in fact, you could say that if you drew a line down the middle here, the right and the left-hand sides are mirror images of each other. This side and this side are identical to each other. That's what we mean by symmetry. And this happens when the mean and the median and the mode are all identical to each other. All right. This is a nice case. Kind of looks like a volcano, doesn't it? This is where the lava would come out. All right. What about the last case? Positively skewed. This is the one we want to see with a portfolio of stocks, by the way. Mean greater than median, greater than mode. This means we have more gains than losses. We say that the data are positively skewed. What does it look like? Well, I'm sure you can figure it out by now. Yes, you can. The gains start right about here, far outweigh the losses. So to use the skiing analogy, this time you're going to come up the slope on the left-hand side. You're going to ski down this side because it's a much gentler slope than over here. This is what you want to see ideally in your portfolio. The gains are greater than the losses. And so we call this positively skewed. There's more area in the right than in the left. And again, this comes about because the mean exceeds the median, which in turn exceeds the mode. So right here, you can already see one of the many ways in which these measures can be very helpful. Okay. All right. Now, what comes next? We're going to look at another set of measures. Before, we were looking at central tendency, the middle of the data. Now we're going to look at something completely different. These are called measures of dispersion. How spread out are the data around a central value? So let me show you a couple of quick examples of that. Before I show you their names. Now, again, some of these names will look familiar to you and some of them might not. So let's just say that we have two samples, just to show you what I mean. We're going to look at, these could be any numbers. Sample 1, the numbers are 1, 2, 2, 3, 3, 4, 5. Sample 2, -10, -5, 0, 5, 10, 20. So which sample is more spread out? Okay. So sample 2 is clearly more spread out than sample 1 because the elements are much further apart. Okay, so visually you can see that sample 2 is much more spread out than sample 1. But it would be nice to have a numerical measure that lets us quantify the spread. Well, fortunately for us, there exists many of these measures. Now, by the way, why does this matter? Well, let's say that these are returns to a stock. The first case, the returns over the last so many weeks have been 1%, 2, 2, 3. The stock on top is very safe, very stable, very predictable. I don't have to worry about the returns being extremely small, but then I'm also not getting any really extremely large ones either. It's a boring stock, but it's safe. The second stock, the numbers are scattered all over the place. We can have really rough years and some really great years and everything in between. So in finance, we would say that the second stock is riskier than the first one because it's more unpredictable. And that's a huge deal. That's a huge piece of information to have as an investor. So this is one of the many, many areas in which these measures of dispersion are quite helpful to us. All right, let's look at the list and we're going to see if there's any old friends here. Oh, there's so many of them. Well, it's a little bit deceiving because some of these are actually closely related to each other. So in other words, they're not all completely new. All right, I think it's time for a fun poll now. You know what? I can actually recycle this one. Yeah, all right, just for the fun of it. Man, only one person voted.
It popped up on the screen and then immediately disappeared.
Oh, it did? Oh, all right. Well, that's ridiculous. I'm surprised to hear that. Is it gone again?
No, the same thing just happened.
All right.
Yeah.
Well, stupid thing. All right. I won't use it today anymore then. You know what? It's like all technology. It never really works the way it's supposed to, does it? No. All right. So we'll have to, but anyway, but you may have heard of some of these, but maybe not all of them. So anyway, some of these are incredibly simple and some of these are actually quite complicated. They'll all eventually prove to be very useful. So the first one, the range, is one I'm sure you're very familiar with. The range is basically telling us the gap between the largest element in our sample or population and the smallest. Okay. It's the difference between the smallest and the largest element, and that's literally all there is to it. So in this case, we've been using up to this point, if you look at these numbers now, like we've seen with the median and the mode, we really ideally should sort these out. It'll minimize the risk of mistakes. Let's put it that way. If we do that, we get -1, 1, 2, 3, and 5. And so you can just literally see that 5 is the largest, -1 is the smallest. And when we subtract that, we get a range of 6. Okay. I can't help it. Let's throw in another quick example here. I think it's good to have plenty of examples. So suppose the GPAs in a class are, and now sort them out. We got somebody who's not doing so well. The range would be 3.5 minus 2.2, which is just 1.3. It's that simple. Okay, that's it. That's all we need to know. But for some applications, this is good enough. You know, you don't always need the most sophisticated measures in the world if you're just trying to get a rough idea of what's happening in a data set. Like, for example, if you look at stock quotes, what they'll often do is, among many other pieces of information, they'll show you the highest price that stock is traded at during the year and the lowest price. And so you could actually calculate your own range by just calculating the difference between the two. And that would be your range. And of course, the range, the wider the range, the more risky the stock really is. Okay. So actually, I forgot to ask right up front, is anybody here actually majoring in any kind of business discipline? Like finance or economics? No, it helps me decide what kind of examples to use if I know what you're interested in. No, well, shying away from those areas.
My major is like a business major, but it's like in shipping. I'm like a.
Oh, it doesn't matter. You still need statistics. Yes, you do. It doesn't matter if you're in business at all, because otherwise, sooner or later, some information will come your way. And it's all statistical information, and you've got to be able to interpret it. So
I'm an economics major. I'm not sure if you heard.
good. No, I'm sorry, I couldn't hear you from over. That's good. Who's in economics? Let's see.
Me, Arbaz.
Where are you? I can't find your name on the list. Oh, no. Oh, there you are, Arbaz. You're majoring in economics. Well, for you, this will be the most important class you'll ever take in your life. Well, okay, maybe not, but everything in economics is somehow based on statistics. And especially as you get further and further into it, the more advanced courses, they're all going to be based on statistics. So for you, this is it. This is critically important material. More so than maybe for other areas. Like if you're studying, let's say, marketing, unless you're doing actual research, it may not be quite as important, but of course you have to understand what all these concepts are all about. But all right, anyway, so I guess everybody else is doing something different. Non-finance, non-economics. That's okay. But you know what? It'll also help you at some point in the future when you actually own stocks and you're trying to understand, what your portfolio is all about. All of this information will eventually come in handy. So, all right. Anyway, now the next block of the quantiles are actually fairly complicated. Let me just show you a quick graph so you can see what this is all about. Here's your data. Here's the minimum value. Here's the maximum. We want to break it up into quarters. Which I'm going to call Q1, Q2, and Q3. This is the bottom 25%. This is the bottom 50%. And let's see. This is the bottom 75% or the top 25%. And then, of course, this covers everything. But in other words, you're breaking it up into essentially 4 equal pieces. And for many applications, that's all you need. Okay. Oh, by the way, I just want to mention, these are a special type of quantiles. These are called quartiles. The word quart is an indication that these are 4 equal sections. But there's others too. The word quantile is more general than that. Now, here's a couple you may have heard about before. Percentiles. Now, a lot of things are measured in percentiles. For example, when you take a standardized exam like the SAT, let's say that you get your results and you're like all happy. Wow, 700 on the math score. You say to yourself, wow, 7 out of 800, that sounds pretty good, but where do I stand compared to everybody else? What they usually do is give you a percentile. Let's say that translates into 95%. What does that mean? That means you did better than 95% of all test takers, which means you're at the 95th percentile. Sometimes the data is broken up into 10 equal parts, which are called deciles. You don't say that quite so often. Then quartiles means 4 equal parts. This is the one we're going to focus on here. Quartiles. They're very useful in statistics. And the quartiles are a special case. Quartile 1 is the 25th percentile. Quartile 2 is the 50th percentile, which, by the way, is also the median. And quartile 3 is the 75th percentile. That's what they mean. And what's interesting about these is that we can actually use these quartiles to define an outlier. We'll get to that later on. But so they have several uses in statistics, but they can be a little bit tricky to calculate. And here's one of the weird things about quartiles. You would think that by now everybody would agree on how to calculate quartiles, but there's actually differences of opinion about what is the most appropriate way to calculate quartiles. So if you actually went into a calculator and put in some data and asked for a quartile, and then you did the same thing with, let's say, Excel, you might get 2 different results because there are different approaches to using quartiles. I don't know how this happened, but that's just the reality. So what we're doing here, you might find something slightly different if you're using, let's say, Excel or a financial calculator. But what we're about to do is one of the approaches that can work very well. What we have to do is sort our data from low to high. And then essentially what we're doing is looking for a specific position within that data. Okay, a position. So these, in other words, let's say I've got the numbers 1, 2, 3, 4, 5, 6, 7. So in this simple case, the position of the first quartile, the n is the size of this sample that I have, or population as the case may be. 7 plus 1 over 4 is 2. So this is my first quartile because it's the second element. 2 times that, if you put a 7 in here for n, you get 2 times 8 over 4, which is 4. And then the third position, again, substituting 7 for n, you'll get 3 times 8 over 4, which is 6. And in this very, very simple case, you've got your 3 quartiles. And you're done. But it's usually not that simple. It's just a coincidence that the numbers in the set are 1 through 7, so that the position and the quartile actually match. We'll see pretty soon that that's not usually the way it works. Okay, but just to get you a sense of what we're trying to do here. All right, so let's try an example. Here's our first sample. Now you have 8 elements here, and they're not sorted. Let's sort them. There we go. This is what we care about. Now, to find the first quartile, the position is calculated as n plus 1 over 4. N in this case is 8 because we have 8 elements. 1, 2, 3, 4, 5, 6, 7, 8. Yes. So we have, oh no, look at what happened. It's the 2.25th element. Now, is there a 2.25th element? Of course not. If there were, it would be somewhere in here. So whatever this number is, it's somewhere between 0 and 3. But it's not halfway in between either, because it's not element 2.5, it's element 2.25. So how do we find what we're looking for? Good question. We're going to resort to a procedure called interpolation. So in other words, we're looking for something in between 0 and 3, which is closer to the 0 than to the 3. 25% of the difference is here. 75 is here. So the value that we need, it's going to be 0 plus 25% of the difference between 0 and 3. Okay, it's got to be at least 0. Then we have to add some more to account for the fact that it's 25% of the distance between 0 and 3. It's 0.75. That's what we're looking for. It doesn't exist in the sample, but as we've seen before, it doesn't have to. Like with the median, it doesn't have to be an actual element in the sample. We're looking for a position that separates the data in such a way that a quarter of them are less than this number, and 3/4 of them are above this number. So let's prove it. Let's go back and look at the original data. So let's say this turns out to be, as we've just seen, 0.75. 2 out of 8, or 25%, are below Let me fix this graph a little bit, this drawing. %25 of the total, 2 out of 8 are below this number, and the rest, 6 out of 8 are above that number. So this is my quartile. And as we just showed, using interpolation, it's 0.75. Oh, that seemed like a lot of steps, didn't it? But once you get the hang of it, it'll be easy to see what you're looking for. All right, did everyone get that? This is one of the calculations I find that people have a lot of trouble with because it's not intuitive what you're doing here. It is up to a point, but I think that it takes a little getting used to. All right. So are we all caught up? All right, well, I guess that means yes. Okay. Now, by the way, so since we're meeting all the time now, this one, I think what we'll do is we'll do the next two, and then tomorrow we'll go back to this and we'll do it all over again, just from start to finish, just to make sure we get it, because it's probably the trickiest of all the measures we'll be looking at in this chapter. So what about the second quartile? Oh, okay. Now remember, let's get a copy of these numbers real fast. -2, 0. Three, 3, 4, 5, 6, 7. So the index that you're looking for here, n plus 1, 2 times n plus 1 over 4. Oh, sorry, that's 8. What am I doing? This time n is 8. (4.5). Now again, there is no 4.5th element. Element number 4 is here. Element number 5 is here. Okay. Q2 equals element 4.5. What do we do to find element 4.5? Well, let's see. If we use linear interpolation, it has to be at least 3 plus half of the difference between 3 and 4. So Q2 is 3.5, halfway between these two elements, which you'll recognize is also the median, because you would just, with the median, you just literally average these two out and you'd still get 3.5. So in that case, you get a break. You can use the median approach, or you can use this index approach with the interpolation.
Dr. Anderson, I have a quick question.
Yes, go ahead.
Figure out how to determine what elements to interpolate between. Like, I know you said.
Oh, there's, let's go back to the list. Right there, it comes from those positions. Okay, so in other words, write these down somewhere. These positions will tell you what you're looking for. Then if it doesn't turn out to be an exact value, in other words, if these positions are integers, you're done. You can just go find those elements and you're good. But most of the time you won't get that lucky. And that's when you need this interpolation process. Okay, so these are the 3 positions. And once you have a position, then you may need to apply interpolation. All right, so that's how this process starts, the positions. All right, So like I said, I think we're going to start all over. We'll do this tomorrow. We'll pick it up here. We'll do it again as if you'd never seen it before, because I know this one is kind of complicated. And then let's just quickly do number 3. Let's see. And I'm going to want to copy these down again. Was it -2, 0, 3, 4? No, it was 3, 3, sorry. Three, 3, 4, 5, 6, and 7. So the index here is 3n plus 1 over 4. Unfortunately, it's not an integer. It's 6.75. So that's going to be 1, 2, 3, 4, 5, 6, 7. Somewhere in here. Well, there isn't one, is there? No. So what do we do about it? So we're going to have 5 plus 3/4 of the difference between these two elements. And that's just going to leave us with 5.75. Okay, so this is how it's done. And again, that's not part of the set, but it will divide the data. You notice how 6 elements are below this point and 2 are above, and that's what we're aiming for. Okay, well, I don't want to scare you off with this. They're not, this is, like I said, this is the most complicated probably technique that we'll do in this chapter and many other chapters for that matter. So we'll stop here. If you want to watch a recording, it'll be ready. It's not ready immediately. It takes a little while for it to be processed. It has to be converted into MP4 format, but it'll be there very soon. And you can watch it. You can read these slides. I will be posting this version of the slides on Moodle, so you can look at it again. And then tomorrow, we'll pick it up from here. Now, what remains to be done is we have to cover the rest of these measures of dispersion. And then we have 2 more measures that represent the relationship between 2 samples or populations. So yes, we're doing a lot in a hurry here, but hopefully we'll get enough practice that we can catch up or keep up with it very easily. All right, so we'll knock it off right here, and I'll see you all tomorrow at the same time. All right, so was that too scary? No? Okay, so you're thinking about it. You're not sure if you should say yes or no.
I think I have one question though, Dr. Anderson.
Yes.
How assignments on, are we just doing it through Moodle, like scanning our work and then?
Yes. What you're going to do is you're going to type up or handwrite your answers, and you'll probably have to do some of it by hand. And then what I usually have had people do is take a picture, unless you have a scanner. Now, I think scanners are the way to go, but if you don't own a scanner, there actually apparently is an app that lets your phone do this. Somebody told me about it the other day. Let me see. I think I have it.
Yeah, I think I had that too.
Like
This thing.
yeah.
Yeah, why don't you give it
Yeah.
a shot? You know how it works. I'm curious because a couple of people sent me one of these and it looked really good. And I mean really good. So since you all clearly have iPhones or something similar like an Android, why don't you give this a shot and let me know how it works, because I'm just curious. If not, then just take a picture. The pictures usually are okay as long as you're careful. You know, you got to be. It is print after all, and you're not taking a picture of like like a snowman or something. If you're not careful, it won't be very clear. So if you take a picture and send it back to me, that should be sufficient.
Cool.
Yeah, it works. It's
All right. I'm
It's
down.
What's the first assignment do?
Oh, no, we're not. No, the first assignment assumes that we've already finished chapter 3, so it won't be due for a while. It's certainly not until next week. Plus, we have the Christmas break, but not that you can't start it right away. If you really want to get jumping into it, it's the chapter three problem set, which is in Moodle, but you'll see that, you know, it's based on the assumption that you've already finished all this stuff.
Mhm.
So, yeah, not this week. That's too soon for that. But next week, you'll probably have to hand in 2 or 3 things to make up for it, though.
Okay.
But yeah, if you want to get started, the problem set is on Moodle right now. You can go at least get started with it if you want to. And in the meantime, you can read this chapter. You can read the next one too if you want, and you should be ready for tomorrow. And if you don't have a calculator, you should go get one. All right, that would be a good idea too. Maybe get it for Christmas. Get a TI-84 for Christmas. Say, I know you've already done your Christmas shopping, but I could use one of these babies. The stores are probably open until midnight on Christmas Eve anyway.
Yeah, exactly.
All right. So I guess I'll just see you all tomorrow then.
Thanks, Dr. Anderson.
Welcome.
Thank you, Professor. Have a good one.
Okay, bye.
Wait, Professor, I actually have like 2 questions actually.
Okay.
So we have classes on Wednesday and Thursday.
Not this Thursday. The school is not open. We're not supposed to have a class on Thursday, so just Wednesday.
Oh, but you just said you'll see us tomorrow.
Oh no, I'm sorry, I meant Tuesday and Wednesday,
Yeah.
but not Thursday. Thursday this week is no school.
Okay. But usually we have classes, but usually like typically it's Tuesday and Thursday.
No, it's going to be Monday through Thursday.
I mean Monday through Thursday.
Yeah, I know it's a lot, but like there's going to be a couple of gaps in there, and also we've got like 16 weeks of material to cover in 4 weeks. So I know it's a lot, but it's not going to happen otherwise.
No,
So
I mean I was just curious because it didn't say it on the syllabus, but I mean
it did. Oh no, really? Oh,
it didn't say the class date, so that's why I was confused.
Uh-oh.
I didn't know how many times a week we were meeting. So we're
Oops.
it's usually Monday through Thursday.
Oh, yeah, it would be. Like if you took a class like this during the summer, it would typically be 4 days a week.
Okay, that makes sense. That makes sense.
So
Wait,
it's the same thing here.
wait, but why aren't we meeting tomorrow? What's tomorrow?
Tomorrow is more of the same. Yeah, no, we're going to be here tomorrow and Wednesday, and then the following.
Okay. I got it.
In other words, it's all this week. We have to stop because of Christmas. We'll have Monday through Wednesday, and then the following week it will be back to Monday through Thursday.
Okay, I got it. Thank you so much.
So, and you'll get invitations by your email anyway, and to remind you.
All right. Well, thank you so much.
All right. See you next time. Anyone else?
Wait, I actually have one more question. I'm sorry.
Okay.
So for the homework, like where exactly is it listed? Like the homework that we have to do for tonight?
Oh, do you have Moodle there in front of you?
Yeah, I have Moodle in front of me right now.
Are you in our course?
Yeah. So it says Math 1600 Chapter 3. So it's the Chapter 3 problem set.
Yes, chapter 3 problem set. Yes, we're doing chapter 3 right now.
Got it. And tomorrow we're gonna have to have all this done.
No, I said no. That one can wait till next week because we're not going to be done with it
Oh,
until
okay.
at least tomorrow. It probably spill over into Wednesday, so that one can wait till next week for sure.
Okay. I got it.
And you can start, but yeah, don't feel like you have to. Besides, we haven't done most of the material just yet, so you couldn't hand it in even if you wanted to.
Got it. That makes sense. And how much is like attendance in terms of like points?
I don't know. It's the thing is some people really can't make it at this hour, and I'm not sure if the school explained this to people properly that we'd be doing these online lectures, but if you're not here, it's up to you then to make sure you watch the lecture, the recording, because otherwise you won't know what's going on. So if you're not there, I won't like call your house and say, where are you? That kind of thing. It's like you should ideally be here, but if you can't make it, you just watch the recording.
Got it. Thank you so much.
Okay.
All right.
All right. Okay. Bye.